All right, here we go. Now, again, over here, first thing at the top, the most important thing for you to do is, which so far everybody in all my algebra classes knew this, so I don't think it's a problem for you guys. So if I said x, y equals 0, what has to be true? What has to be true?
One of them has to equal 0.
One of them has to equal 0. All right, that's all. All right, when you multiply two numbers together and it's 0, then one of them has to be 0. Technically, could both of them be 0? Yeah, technically both of them could be 0. So again, the lesson today is we're going to put a quadratic, which is nothing more than to a second power, and we're going to set it equal to 0. All right. Now, we have the ability to solve right now only something to the first power. Now I'm showing you how you can solve something to the second power, something to the third power, something to the fourth power. All right. And one of the fundamental theorems of algebra is the number of solutions is the degree. All right. So when you have, for example, x squared, that means there are 2 solutions. If I say x cubed, there are how many solutions? If I say x to the 4th, there are 4 solutions. That is correct. All right. So now let's get to the process. All right. The process, again, is very simple. All right. So this has already been factored for us. How many factors are there here? Good. There are 3 factors. 1, 2, there are 3 factors. All right. So if those equal 0, that means one of those 3 factors has to equal 0. So it equals 0 when the first variable, which is x, you just come down and write x equals 0. Then technically you're supposed to write or x minus 8 equals 0, or 2x minus 5 equals 0. All right. That's the situation. All right. Now what you do is you just solve each individual equation. So x could equal either 0, 8, or what? Good job. 5 halves. All right. Now, how did I do that? All right. I just basically looked up here at the equations, and because we are experts at mental math, we can just solve those. All right. For the first one, it's already solved for us. It says x equals 0. On the second one, we just solved x minus 8 equals 0, which was 8. And then on the third one, we just solved 2x minus 5 equals 0, which is just 5 halves. All right, so those are your 3 solutions because there were 3 factors. All right?
That's it.
Now, yes, that means if I were to plug x in here, here, and here, the answer would be what? 0. If I plug 8 in here, here, and here, the answer would be what?
0.
If I plug 5 halves in here, here, and here, the answer would be what?
0.
The answer would be 0. That's how simple it is. Super, super important. All right, you'll be doing this for all of your math careers. Solving quadratics is what this is called, by factoring. Yes. I added 5 and divided by 2. All right, next year your math teacher's probably going to say show all your work. And so if you have to show your work, you would put plus 5, 2x equals 5, divide by 2, divide by 2. But of course, I never did that. All right. Yeah. All right. And your math teacher might next year be mad at you for doing that. All right. Because they won't be able to imagine that you can factor in your head and you can solve equations in your head. You'll be amazed. All right. Well, yeah, 2 years from now. Thank you. All right. Lucky me. Lucky me. Lucky me. All right. So here we go. For question number 6 now, as we go down the page. The first step is always find if there is a GCF. So there's an x. So all we do is we factor out an x. So we put x, and then we say what? X minus 11. All right. Now, again, I'm not kidding. If you're slow here, that just means you haven't been doing the factoring worksheets. That's all it means. All right, it's easy to tell. You should be able to zip through this page pretty quickly. All right, so now you're supposed to set the individual factors equal to 0. So everybody's supposed to write x equals 0, x minus 11 equals 0, and then you solve those individually. But do I make you do that? No, because we are brilliant. All right, if you can't solve those two equations, we're in a lot of trouble. All right, you can't even factor probably. All right, so I would want everybody just to write down x equals 0 or x equals 11. You're allowed to write the answer after you factor it. You're allowed to write the answer after you factor it. So now, just stressing, if I were to plug 0 in for x, I would get what? If I plug 11 in for x, I would get what? All right, now it's easy. All right, so now let's go on to question number 9. All right, here we go. I need some help factoring this. So as soon as you know it, just tell me. I'm listening. X plus 3, x plus 3, and x plus 24. Brilliant. The factors of 72 are 3 and 24 that make 27. Now, of course, 72 is a little bit harder because there's a lot of factors. All right. So now we would say that our solution is what?
Either
X equals -3 or x equals -24. All right. Any issues with this? Anybody? All right, let's check out 12. All right, so again, I'm just trying to factor. Say it again. 5x minus 3 and x minus 3, of course, we'll check. -3, -15 makes -18. So that is correct. All right. And so now we say the solution is x equals 3/5 or
x or 3.
Yep. All right. Now, once again, if I plug 3/5 in for x, I will get a what as an answer? 0. And if I plug 3 in, I will get a what?
0.
I will get a 0. That's how easy it is. Factor, set the factors equal to 0 and solve. Simple as that. All right. Here we go. 15. Now remember, it's not doing any good just to listen to someone else tell you what the factors are.
I got it. 8x minus 1 and 2x plus 9.
8x minus 1 and 2x what?
Minus 9. Oh, plus 9.
2x plus 9.
Said that.
Again, we can double check. -2 and +72. -2 and 72 makes the 70. Everybody good with that? Nothing to it. All right, so now once you have that, you just write down x equals, what is it? 1/8. -9/2. Now remember, don't make a silly mistake on that. All right, everything is equal to 0, so you move the 9, it becomes negative, then you divide by 2, -9/2. All right, if you're not sure, I need to address that and make sure you understand what I'm saying. Anybody have any issues with x equals 1/8 or -9/2? All right, like I said, if you know how to factor, then this is a breeze. All right, here we go, next. Now, I want everybody to take a look at this. All right, GCF is what? 4. Now listen, I need everybody to hear me on this one. All right, 4 is a constant. It has no variable. So how you handle this is literally you're dividing the equation by 4. All right, when you divide the equation by 4, it makes the factoring much easier. So now this becomes x squared minus 12x plus 36 equals 0. What? Because you didn't divide out the constant first. It's not that you're going to get a different answer. It's just much easier to factor. That's what I was trying to say. All right, it's much easier to factor. You should always divide out the constant, always. It makes the factoring much easier. What? I didn't hear you. Because constant is called a number, as opposed to a variable. Like if 3x, that would not be a constant. That's a variable. You can't have a number. What do you mean? Yeah, the 4 is a number which is referred to as math. We call that a constant. It stays the same. It doesn't change. Yes, that's what I said. All right, thank you. All right, I'm dividing by 4. Now, do you agree it's much easier to factor? Right? And some of you are like, no, I can do it. I promise you it's easier. If you have a common factor, you should always divide out the common factor. Now, when you factor this, this becomes what? Right, so everybody should be able to quickly tell me that's just x minus 6 times x minus 6. So in math, we just write x equals 6. We don't write 6 comma 6. We don't repeat answers. But I would like everybody to write down in their notes, this is called a double root. I can even hear it from here. Yes, I can hear. Right? I'm telling, just talk to me. All right? You're interrupting people who are studying and listening. It's rude. That's what I'm here for. So this again is called a double root. We call it a double root because this x equals 6 is the solution for both of them. All right? Now, it also is called, or the answers are also called the zeros. All right? And again, we'll talk about that more. All right? But this is a double root. Anytime the solution occurs twice, we call it a double root. All right? Now let's look at this guy. What do we think I have to do here? And how many solutions are there going to be? How many solutions are there going to be? 3. And everybody knows there's 3 because you're looking at the degree or the exponent. The largest exponent is a 3. Therefore, there are 3 solutions. So how do I factor this? What's it called? Factoring by grouping. All right? So the first thing is we factor out the x squared. And you end up with x what? X plus 1. Then you're factoring out a what? A negative 4, and you're left with x plus 1. All right? Now, this right here is common. So now you have x plus 1 times x squared minus 4 equals 0. And then we're almost done because is everybody okay with that? Anybody have any questions with that? So now here's how you write the answer. Let's see if you're following along. All right, you could say x equals -1, -2, or 2. But in math, there's a quick way to write -2 and +2. We say x equals -1 plus or minus 2. All right, that's what that symbol is. The answer could be 2 or the answer could be -2. And again, those are all 3 of the solutions. All right, very simple. Factor, set the factors equal to 0, and then solve. And that's your solution. All right, so here we go. What? All right, so what's wrong with 24?
It's an x squared minus 0.
Tell them. Right, because it's not set equal to 0. All quadratics are always going to be set equal to 0. So I have to move them. And then when I move them, all I have to do is what? Change the signs. So I'd like everyone to rewrite this as x squared plus 10x plus 25 equals 0. Anybody have any issues with that? And so now that factors to what? Right, x plus 5 times x plus 5. And so this is called a what? Double root. And I'm just writing it because you will be talking about it a lot in the future. This is called a double root. X equals negative 5. Say it again.
How come the exponent times the second power is not the
Yes, that's a brilliant question. There should be what? 2 solutions. That's why they call it a what? Double root. All right, that's why they call it a double root. You with me? All right, here we go. What's the problem? You got to move the 6 over. So that becomes x squared minus x, what? What? No, we want the x squared to be positive. So it'd be what? Minus 12 equals 0. X squared minus x minus 12 equals 0. Anybody have any issues with that? And now what? Yeah, everybody should be able to rattle that off. X minus 4, x plus 3. So x is equal to what? 4 or, yeah, negative 3. 4 or negative 3. Anybody have any issues? All right, let's find something else now. Let's take a look at 28 or 30. Again, what's the problem? Move it over. So what does it become? Beautiful. And so what happens now? Come on. Yeah, so my solution is, yeah, you guys, it's really simple once you get the hang of it, especially if you're good at factoring, nothing to it. Anybody have any issues with this? All right, let's check out 33. Okay, now 33 is considered the hard one. All right, because I can't just subtract 6. All right, so listen, I have to multiply this out first. All right, I have to multiply this out first. Now again, everybody look up, because here's how fast you should be. You should be able to look at that and say that's just x squared minus 7x plus 12 equals 6. All right, if you don't know how to do that, all right, you're a little bit behind. Remember, you're grouping here. How much is this? Negative 4, and this is what? That's how I got the negative 7. Come on now. I want everybody to be able to multiply a quadratic in your head. All right? Anybody have any issues with that? All right. Now we have the next step, which is all quadratics have to be set equal to 0. Go. You are great. X squared minus 7x plus 6 equals 0. Now what? Beautiful. So now what? That's it. That's how simple it is. X equals 1 or 6. All right. Every quadratic has to be set equal to 0. All right, here we go. I'm waiting patiently.
2x minus 3 and x plus 3.
Wow. Say that again.
2x minus 3 x plus 3.
Is he correct?
And then x equals 3 over 2 on the negative 8.
That's not bad, right? Again, if you can factor. I know some of you are like, oh, I'm just slow. Yep, there's nothing I can do. All right. Some of you are just slow.
Why are you looking at me, man? Huh?
That was an easy choice. All right, here we go. Let's knock out 39.
Easy. Yeah, so easy to draw. Like, you just like video art.
5x plus 2 x minus 1 x equals negative x equals negative 2.5 on that 1.
Some of you said 1 over 1. I heard that.
1. It is 1.
That's embarrassing.
1
1 over 1.
Me, there was no negative 1. Like, don't talk.
Trust me, I'm not having any problem not talking to you. All right, here we go. 43. Uh-oh. Oh, that's what I said. Oh, yeah, mark me. Yeah, mark me wrong. Mark me wrong. Go, Catherine's got this. Shh.
3x plus 2 and x plus 5.
Are you sure?
Yeah.
Okay, okay.
Are you sure?
X equals negative 2 over 3 and x equals negative 1.
Right, very nice, very nice.
Yeah.
Yeah, you're not supposed to write down my answers. You're supposed to do it yourself.
I haven't even done this. I'm just checking my question yet. You guys are already shouting.
We can't help if you're slow, Luke.
Yeah, come on.
Slow. Middle name. Lucas, slow. All right, 45. All right, slow down on this one, Lucas. Give him a chance, guys. Give Lucas a
Oh,
chance.
this is hard, Lucas. I don't even know it.
All right, Lucas, what are we thinking here? Is not an answer. What is the answer?
This is wrong. I know the answer because
Shh, no one's talking to you. Again.
Comma. The answer is comma. 5 over 3.
Brilliant. Negative 1/2 and 5/3. All right, again, for some strange reason, when kids see this, they think they're supposed to multiply. You're not supposed to multiply if it's equal to 0. All right, it's already factored for you. Your objective is to factor, set the factors equal to 0. All right, here we go. 48.
Oh.
Yes. Add 15 first.
So 4x
All right.
plus 4x equals 0. This is what's the answer.
All right. Now I need a GCF.
4x.
Yes. So we're going to pull out a 4x. And what's left behind? Yay. X plus 1. All right. Final answer. What is it? No. Say it.
Negative 1.
Stop.
Negative 1.
Harrison, would you just tell him the answer, please? Thank you. 0 or negative 1.
Oh.
Yeah, okay. For those of you guys who are struggling, that means you're asking me 4x equals 0. What is x?
This girl hit me live.
And then x plus 1 equals 0. Slow down. All right, not trying to make you look bad or anything, but you're welcome. Good. All right, no. Here we go. 51. Shh, 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 shh. Get it factored. 3x plus 2 and what? Anybody else? And what? X minus 3? No, I'm asking you what the factor was. I can't hear it. Is that right? All right. X equals. Very good, Olivia. X equals negative 2/3 and 3. Very good. All right.
Whoa.
All right. Last one for the day.
I got this.
Nate,
Okay, so 4x plus 3.
hold on a minute. And then
X plus 1. And negative 3 over 4.
This is for all of you, love me.
And then negative 1.
perfect.
See that?
Negative 3/4 and negative 1. Easy, easy, easy.
Mr. Strong.
All right. So now listen, guys, for us, all right, very easy if you know how to factor. All right, the rules of the game, factor, set the factors equal to 0. Now on Tuesday, just to give you a little quick heads up, on Tuesday we'll be finishing the worksheets.
What?
All right. Then on Wednesday and Thursday, I'll prepare another worksheet that'll probably have another 10 or 12 problems. And then our quiz is going to be a quiz because really all it is just solving by factoring. That's it. Now listen, again, all right, really and truly, graphing lines, knowing how to graph lines and knowing how to solve quadratics are one of the most important things that you do. All right, you'll always be doing it. That's why I said there are no shortcuts. Those of you guys who did all 150 or whatever factoring problems, it should be a breeze. All right. If you're a little bit slower, that's because honestly, you haven't done them all, or you didn't listen to my advice on how to solve or how to factor some of them. All right. So again, if you're struggling, spend some time over the weekend and practice a little bit. Go back to the old worksheet and redo them. All right. If you are good, we have no homework. All right. There's nothing more to do, but I'm telling you on Tuesday, all right, we will finish this up. Wednesday and Thursday, we'll have a review. The end.
You see these assignments, this one, can I do them over the weekend and make them go to 100 or 90?
If you didn't do them,